Hello kids, ladies and gentlemen. We are on Unit 6, Day 9. All right, so we're going to be talking about the equations of tangent lines. Okay, so before we get started, let's take a look at exercise 1. All right, so given a line segment AB with endpoints -3, -3, and 3, 6. Excuse me. Answer the following question. So determine the slope of AB, okay, and then determine the slope of a line perpendicular to AB, okay? And so we're going to be basically practicing writing equations again, okay? This is something that some of you do need to work on, or all of you, right? Something that we need to be able to do, and so let's get started here, right? So how to find the slope, right? To find the slope, we would use this equation right here, okay? This equation right here is the slope formula, right? Okay, which gives you your slope based off of 2 points. So, I see 2 points here, so I'm going to go x1, y1, x2, y2. I'm just going to sort of plug those guys in, right? So 6 minus a -3 all over 3, whoops, again, minus a -3. So this is going to be 9. This is going to be 6. Simplify that out. It's going to be 3/2, right? So our rise is 3, and our run is 2. Remember, rise over run, right? So when we go to do this slope, we would go up 3 over 2. Up 3 over 2, right? Or to the right. We always go to the right. All right. So anyway, here's our slope, 3, 2. So the slope of a line that would be perpendicular to that guy, okay, would have to be the negative reciprocal, which would be -2/3. And then finally, it's asking write the equation of a line that passes through point B that is perpendicular to AB, right? And so in order to ensure that, okay, what we need is we need to not only go through this point, so we're going to need this point right here, right? But it also needs to be perpendicular to our line segment AB, right? Which means we're going to need this slope right here. Okay, so the equation looks like this. This is called the point slope formula. And it looks like this. Y minus y1 is equal to m x minus x1, where x1 and y1, okay, yeah, that's sloppy looking, where x1 and y1, okay, is actually our point we're going to use, right? So we're going to use this as our point. Then our slope is -2/3, and so we just plug that in. So y minus 6 is equal to -2/3 x minus 3. All right, and then we're going to distribute that -2 in there, -2/3. So we're going to get y minus 6 is equal to a -2/3 x plus 2, add 6, so y is equal to a -2/3 x plus 8. Okay? And so the reason why I distribute that out, because our last question is asking what is the y-intercept of this line, okay? So if we wanted to, we could have just graphed what we had there, but by putting it in the slope-intercept form, okay, now we just already have that information, right? So +8 is our slope, and we're going down 2 over 3, down 2 over 3, down 2 over 3, up 2, back 3. There's our line, and then let's just plug in AB there, right? So AB was negative 3, 3, or negative 3, negative 3, sorry. And the other point was 3, comma 6, right? So 3, comma 6. So there is that line segment. Okay? And as you can see, it looks perpendicular to the other one, and it's going through that point. Okay? So the reason why we're doing this is this, right? Because we're going to be finding the equations of tangent lines, right? And so remember, our tangent lines, okay, if this was a circle here, let's see if I can sort of make one up. Here's our circle, right? Let's see if this comes out even. I guess close enough, right? So, whoa. This would be like, so kind of a crappy picture, but this is what we're looking at, right? So these tangent lines are always going to be perpendicular to our radius at a particular point, right? And what is that point? That point where they intersect. So what we're going to be doing is we're going to be finding, this equation here, this line segment, all right? And then we're going to be finding the equation of the line that's going to be tangent through this particular point, right? Tangent to the circle, okay? And will also be perpendicular to that radius, okay? So that is our goal for this lesson here, right? So let's take a look at number 2. Okay, so circle A is shown below with a center at the origin and a radius of 5. Okay, point B lies on the circle and has coordinates 4, 3, which is the point B. The tangent to the circle at point B is drawn. So write the equation of the circle below and show that 4, 3 must lie on it. Okay, so the first thing we have to do is, well, our origin, looks like our circle's at our origin. So the equation of this guy is going to be x squared plus y squared is equal to, and our radius is 5, so 25, right? That would be the equation of that circle. We want to make sure that 4, 3 falls on that. Okay, so here's our point. Here's our triangle created by 4, 3. So here's 4, here's 3. So we're going to use a squared plus b squared is hopefully equal to this length right here, which should be 5. So 5 squared. Okay, so 16 plus 9 is equal to 25. And 16 plus 9 is 25. So 25 is equal to 25. So it checks out. So 4, 3 does lie on the circle. Then it says, what is the slope of AB? Okay, well, we could find that out real quick. We could either do the slope formula, or let's just count up from A to B. So I'm going to go up 3 over 4. So our slope is up 3 over 4, right? Up 3 over 4 is our slope. So write the equation of line M in point slope form. Okay. So, well, what do we need here? If I'm going to write the equation of this line, I know that this line here and this line here are perpendicular, right? Okay, which means that the slope of line M must be negative 4/3. And then we want to go through which point? Well, 4, 3. Right, that appears to be the point that it is touching, right? It is touching our circle. So we're going to go y minus 3 is equal to a negative 4/3 x minus 4. All right, and then when we actually, right in point slope form. Perfect. We're done. Psych. It appears that line M has a y-intercept of 8. Prove or disprove this observation. Okay? We're going to actually disprove this. Okay? And so what we're going to do is we're going to distribute this through. So y minus 3 is equal to negative 4/3 x plus 16 over 3. I'm going to add 3 to both sides. And so y is equal to negative 4/3 x plus, and 16/3 plus 3 will give me 25/3. 25 divided by 3 is actually 8.333. So no, our y-intercept is not 8. Okay? And we basically just shown that by distributing that slope through. Okay? And as you can see, we get 25/3, not 8. Okay? So the key to writing these equations is the fact that the tangent will be perpendicular to the radius at the point of tangency, right, where these circles and these lines meet. Thus, the tangent and the radius will have slopes that are negative reciprocals, okay, because they're perpendicular, right? I've said this before, I'll say it again. Lines that are perpendicular have negative reciprocals for slopes, okay? So, that being said, take a look at exercise 3. Consider the circle whose equation is this, and the point is this. Use of the grid is optional, but helpful to visualize what is happening in this problem. Okay, so first let's visualize what's happening in this problem. So our radius squared is 80, and so the square root of 80 isn't anything nice. 8.94. So I'm just going to run it at 8.9. So our radius is almost 9, right? I mean, 81 would have been perfect. But, of course, it's not, right? So let's put this guy on the graph. So 6. So our center point is 6, comma, negative 3. And our radius is 8.9. So 6, comma, negative 3. And our radius is 1, 2, 3, 4, 5, 6, 7, 8. Right there. 2, 3, 4, 5, 6, 7, 8. Right there. And that's about all of the circle we're going to, all we're going to see. Okay, so here's our center point. Let me make that nice and big. And that's about all we're going to get. Let me make a better one. There we go. Something like that. All right. So what are we trying to say? We're trying to show that point A must lie on the circle. Okay, so where is point A? 2, comma 5. Let's put that in there. So 2, comma 5. Now, based off my drawing, it doesn't quite look that way, right? But, again, this is just a sketch. So let's figure out if it is actually going to be on there. All right, so here's our distance there, right? So our radius, this distance should be 8.9. So this guy right here is going to be, well, this looks like it's 4. And this looks like it's 1, 2, 3, 4, 5, 6, 7, 8. Okay? So we're going to use Pythagoras Theorem. So 8 squared plus 4 squared is equal to c squared. And basically we're looking for 80, right? So this is going to be 64 plus 16 is equal to c squared. This is going to be 80. And then so c is equal to the square root of 80. So we're good, right? It falls on the circle, right? We just found that this radius right here is 8,9, or 8.9. So we're good. So find the slope of the line segment that connects the center of the circle to point A. All right, so let's erase some stuff here. Okay, so let's just visualize this a little better. Okay, suppose it is on the circle. There's our radius. All right, and so find the slope of the line segment that connects the center to the circle, or center of the circle to point A. Okay, so this point is 2 comma 5. This guy is 6 comma negative 3. So I'm going to go x1, y1, x2, y2. So negative 3 minus 5 over 6 minus 2, negative 8 over 4. So the slope of this line is a negative 2 over 1. And you can kind of see that, right? Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And so now it says write the equation of a tangent line to the circle at point A in point slope form and slope-intercept form. Oh, you son of a gun. Well, that's all right. Okay, so we're looking for the equation of this line here. So let me see if I can draw this in here. Okay, well, I don't want to do red. Let's go blue. Okay, so we're looking for the equation of this line right here that touches our circle at that point, 2 comma 5, right? And is also perpendicular to our radius. Both of those things will make this guy tangent to our circle. Okay, so what do we need? Well, our new slope, right? We're going to need a new slope here. And so the slope of this line that's going to be perpendicular to our radius is going to have to be a positive 1/2. And then our point that we're going through is 2 comma 5. So let's plug it in. So y minus y1 is equal to 1/2, m x minus x1. Okay, so let's just plug in the blanks here. This is going to be y minus 5 is equal to 1/2 x minus 2. So that's point slope form. And then we distribute this through, bring the 5 over to the other side. So let's see, so y minus 5 is equal to 1/2 x minus 1 plus 5 plus 5. So y is equal to 1/2 x plus 4. Which, as you can see, right, a y-intercept, if my graph was drawn correctly, would go right through that point right there. So I'm pretty satisfied. That looks pretty good. So here's both of our answers right here. Okay, let's go on to the last problem. So exercise 4, and this will be the last one for the day. Okay, so given the equation of this circle, write the equation of the tangent line to the circle at this point. Okay, so let's graph this guy here. Okay, a big old graph here. So let's go. There's that one. There's that one. Okay. Our center point, negative 4 comma 2, and our radius is the square root of 136. Which is equal to, oh, I don't know, 11 point, we'll round up, 11 point, whoops, come here. So it's going to be 11.662, okay? So let's draw this circle on here, all right? So negative 4, comma 2. So there's our center point. And we're going up 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just a little bit above it. 3, 4, 5, 6, 7, 8, 9, 10, 11. Just a little bit above it. Whew. Squeezed it in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oops. A little bit farther down. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Boom. Okay, so here's my crappy circle. Ugh. Let's try that again. Come on. One more time. That's not going to work out again, is it? Jeez. See if I can get it when it's a little bigger. Here we go. A little better. All right. Okay. Draw this in here. Good enough. There we go. Okay. So there's our circle. And then drawing a line that's tangent to it at this point. So 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So not a bad circle, Mr. K. Almost lands right on there pretty well. Okay. So write the equation of the tangent line for that circle. So your tangent line looks something like this. Okay? Will look something like that. And it's going to be perpendicular to our radius. Okay, because all tangent lines are perpendicular to the radius. So, let's see. So we need this point, 2, 12. We need to find the slope of this line here. So a couple ways we could go about this. I could just count up to this point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So up 10, and then over 1, 2, 3, 4, 5, 6. Right, up 10 over 6. So if I were to simplify that, that would be up 5 over 3. Let's see if that works. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, and 3. Okay, so I'm satisfied. So here's the slope of our radius. So what do we need? We want the slope of that tangent line. So new slope, our new slope is going to have to be a negative 3/5. And then our point that we're going through is 2, 12. Okay, so let's just plug it into that equation. So y minus 12 is equal to a negative 3/5 x minus 2. And so just write the equation of the tangent line. So we could either leave it like this, or, because this is point slope formula, if you want the slope-intercept, okay, you would have to distribute this through. So we get y minus 12 is equal to a negative 3/5 x plus, so that's going to be a 6/5, and then plus 12, and so this equation is going to be equal to y is equal to negative 3/5 x and 6/5 plus 12 is either equal to 13.2 or 66 divided by 5. Okay? So, two different answers there, but they're the same thing. Okay? So anyway, if you're watching this, hopefully I taught this lesson in class and you're just going back for reassurance on how to find these. Okay? But the key part is your radius is always perpendicular to the tangent line through whatever point that tangent line intersects your circle. Okay? So in all these cases, right, our radius is perpendicular, and when you're trying to come up with two lines that are perpendicular to each other, remember you need negative reciprocals for slopes. Okay? So hopefully this helps. Hopefully this isn't too long, but it probably is.